Hey, good morning. It is Friday. Everybody is on a video lesson today. Mr. Farr's only teaching part of the day, and then I'm out. So watch the video lesson. You got entry activity number 14, and then linking literacy. So let's keep it pushing right now. Make sure to get this written in your agenda because we are having a journal check next week. So make sure you got that. We are having a journal check next week. I was going to try and make you turn it in online, but instead I decided I'll just check it tomorrow. I mean, not tomorrow, probably like Monday. All right, next week is Red Ribbon Week. So Monday is business, is Men in Black. So suit up against drugs, business attire. So wear business attire, wear like a suit, right? I'm excited for that. Tuesday is Top Gun, stay out of danger. So that's red, white, and blue day. Let's go. Stay out of the danger zone, right? Wednesday is Barbie Day. So you are enough to stay away from drugs. Wear pink. Let's go. And then Thursday is Hocus Pocus. Don't let drugs put a spell on you. And then just wear your costume. All right, y'all. That's that for that next week. So make sure that you're ready. Participate. It's fun. I'm excited. All right, here is everything for the journal check. So look at that. We got inertia, frame of reference, acceleration, Newton's second law, direction, mass, scalar, vector, velocity, net force problems. We got kind of a lot. So we're going to do some more of those things today. So make sure all of those things are in your journal. So you should open up your journal right now and be like, how many of those things do I got? I will tell you right now, scalar, vector, velocity, we're going to do those today. You should have net force problems already in there. You should have direction, Newton's second law, acceleration, inertia in there. We're going to do frame of reference and mass as well today. So we're going to revisit that. So we got some things to do today. So make sure you stay locked in. Let's go. Okay. Go ahead and pause the screen. Again, pause the screen and then get this done and then we'll work through it. Okay. Did you work through that? Or are you just waiting for Mr. Farr to do it? Because I'm telling you, if you're always waiting for me, then you're missing out on your opportunity to get reps. So if you're like, oh, you know what? I really just didn't pause it. I'm like, no, pause it right now and get it done. Okay? Pause it right now and get it done. Okay. So let's just read through these. How much force is required to accelerate a 795 kilogram Lorenzer speeder by 15 meters per second squared? So if we look at everything, we're like, oh, they're asking us for force. That's cool. So force is equal to mass, right? Mass times acceleration. Okay, cool. So here's the question. Do I have the mass? Yeah, I got the mass, 795 kilograms. So I'm going to go right there, 795 kg, right? That's the mass. Boom. Times, oh, and I have the acceleration, 15 meters per second squared. Let me move myself about the way now. Blah. So, again, the acceleration, all right, let me see. Oh my gosh, my little pencil's going crazy. All right, so the acceleration, bam, right? And then the mass, bam, okay? And again, mass times acceleration, so there's mass times acceleration. Then that is equal to, and let's see what we're going to get here. I'm going to go ahead and pull up my handy dandy calculator, blat out. So let's move this thing over here and then say 795 times 15 is equal to 11,000. That's a lot. 11,925 newtons. So 11,925 newtons. Nothing too crazy. We don't got a round. Okay, cool. All right, so let's go and check on this bottom problem. So again, how much force is required, right? So how much force is what they're asking for us to accelerate a 142 kilogram baseball to 44.7 meters per second squared. Okay, cool. So again, force is equal to mass times acceleration, which is going to be equal to, the mass is the 0.142 kg times, and then we have the acceleration, which is going to be the 44 0.7 meters per second squared, right? So again, this is the mass right there, and then the acceleration is all the way over here. Let's go ahead and do the math, right? Let's go ahead and get the math going. Boom. And then the math is going to say, all right, 0.142 times 44.7 is equal to, and again, we're rounding to one decimal place, right? So we'll go ahead and I'll put the answer up here. 6 point, and I got to look at that again because I got to make sure I'm rounding correctly. So when we're looking at this, oh, hey, 5 or more up to score, 4 or less, we're going to let it rest. So it's going to be 6.3. And since it's force, it's 6.3 newtons. So this is the answer right here. And then up here, here is the answer right here. So make sure, right? Make sure that you got those in there, okay? Hopefully that was easier for you to solve today than what we saw yesterday. But we'll keep working on these problems little by little, and then you guys will get them. Trust me, but you got to actually try and get the work done. Okay, cool. Let's move on to the next thing. All right, so we wrote down a generic definition for mass. Just get this one down real quick. I'm going to talk about it. You may need to pause the screen. So mass is a measure of how much matter is present in a substance. Again, mass is a measure of how much matter is present in a substance. And this is a little bit of a better definition than just saying all the stuff that something's made of, but this is like the measure. So when you get that grams or that kilograms, it's the measurement of how much matter is present in that substance or in that thing or object, right? Okay, cool. So pause it if you need to get this written, but I'm going to move forward. All right, cool. Now, write all of this down. I'm going to explain and talk about this, but write all of this down. This should be a full page. So take a whole page to write this down, okay? And there's just a lot of little bubbles and a few little things you got to write in each one. So this is forces in general. And we got two different branches, as you guys have already been saying. We got forces that are balanced, and then we got forces that are unbalanced, what you see at the bottom. So let's just talk about the ones that are balanced. If the forces are balanced, then the motion of the object does not change. So whatever motion it currently has, it will remain with that motion, right? So it'll keep in that motion. And then also for balanced forces, forces acting on the object are equal in magnitude. That means they are equal in size. When we say magnitude, we mean they are equal in size or equal in strength, right? But they are going to be opposite in directions, okay? They're going to be opposite in directions. So again, balanced forces are going to, the motion of the object does not change. These forces are acting on objects, and the forces are going to be equal in strength. So the amount of them is going to be equal, but they're going to be opposite in directions. Okay, cool. Let's move on down here to unbalanced forces. They're going to result in a change of motion, and that's what we've seen. When the forces are unbalanced, we've seen objects go in motion, right? Things move when the forces are unbalanced. So when forces are acting on an object, they're also going to be, forces acting on an object can be opposite in direction. They also can be moving in the same direction. That's the thing about unbalanced forces. Unbalanced forces can move in the same direction, or they can move in opposite directions, right? So they could go either way. Now, they are not going to be equal in magnitude. Again, they are not going to be equal in magnitude. There will be forces acting in opposite directions, very typically, but also there are going to not be equal in magnitude. So usually, like tug of war, like someone is pulling with more strength this way, so the object's going to go that way. All right, cool. So hopefully you guys got all of that down, and we're moving on to the next slide. All right, so frame of reference, and no, you don't have to draw all of these things, but we'll talk about this. A system that coordinates, a system that uses coordinates or background objects to establish position or to measure a movement in the point of space. Just get this one written down. I'm going to talk more about it on Monday. I think it'll be easier if I'm explaining and moving around the classroom. So just get this one written down, and then we'll talk about it on Monday, okay? We'll talk about it on Monday. All right, on to the last thing. Oh, sorry. Do you need to pause? You need to get that. So just get this written down. We'll talk about it on Monday. On to the last thing. All right, So yes, you need to draw all of this, all the little things, draw all the little things. So scalar versus vector. This is very simple. It's not too crazy, but a scalar quantity only has a magnitude. So speed is a scalar quantity. When we say it only has a magnitude, it only tells you how fast it's going. So if we say, oh, that boy was running at 10, like, oh, that boy was running in the football game, he was running at 22 miles per hour. That is only the speed. That is only the scalar quantity, right? So it's only his magnitude. So how fast is he moving, right? But if it's a vector quantity, it has magnitude and direction. So again, magnitude and direction. So how fast are you going plus what direction are you heading in? So it's two things, speed and direction. That's what we would call, everyone say, velocity. So velocity has speed and direction. It has both of these things. So make sure that you've got that in there. So again, scalar, which is speed, is just saying how fast is this object going. And then vector, which is going to be velocity, is going to say how fast are they going and what direction are they heading. Okay, so get all these in there. Get yourselves a couple examples there too. Make sure you got all this written. And then that is actually the end of the notes for today. And thankfully, that is like the majority of the notes for this chapter. This chapter has a lot of notes, a lot of definitions, a lot of things to learn. Remember, we will be having a quiz next Wednesday. So we will be having a quiz next Wednesday. We cannot put it off any further than that. So we'll be having a quiz next Wednesday. So make sure you're studying. All of these definitions will show up. I'm just telling you right now, all these definitions will show up. I'm going to try and build the quizzes over this weekend. I may not have time, but I will have it up by Monday, but I'm going to see if I can get it up sooner than that. But obviously you have all these definitions and you have all these terms and you have some of these problems that we work through. Study and read and understand, okay? Because all of these things are the things that are going to be on there. All right, lastly, you got this linking literacy. So just finish this. That's it. It's due today. So there's 2 pages. There's some readings. There's some examples. This is a way to study and be prepared for the quiz that we're having next week. So this is a way, again, to study and prepare for the quiz we're having next week. I would also these are the things that I would do today. Finish this linking literacy. Then the next thing that I would do, is I would be like, okay, let me review for the quiz. So again, review for the quiz and then catch up and make up anything that you have missing or that you need to get done for any of your classes. Other than that, that is it. All right, y'all. Peace. Love y'all. See you on Monday.